Welcome to the Digital Twin Talks by the National Digital Twin Programme. I'm Simon Evans from Arup. I work closely with the programme and I have the privilege of facilitating this first series of talks on digital twin concepts, where over the next 4 weeks we'll be hearing from experts across industry on what underpins digital twins and why they're important for us. This will culminate in a live panel discussion with all of our speakers on week 5. All of these talks will be hosted here on the Digital Twin Hub, where we'll also have discussions both during and after each session. So I really encourage you to get involved in the conversation, ask those challenging questions and share your views. So digital twins mean many things to many people. Some see them as a technology or product, while others see them as a methodology, an approach and way of working. However you view digital twins, it's fair to say they're probably here to stay, and they're going to have a dramatic impact on society, the economy and environment. Now, of course, digital twins are exciting, but when you start connecting multiple digital twins together into an ecosystem, that's when it really gets interesting, which is why many people draw parallels between this ecosystem of twins and the World Wide Web. With that in mind, let me introduce Olivier Theroux, Head of R&D at the Open Data Institute. He'll be sharing the ODI's research and perspectives on moving towards a web of digital twins. Now, Olivier and the ODI are the perfect start to this Twin Talk series, particularly as one of the founders of the ODI, Tim Berners-Lee, is best known for being the inventor of the World Wide Web. Over the next 20 minutes, Olivier will be exploring what it means to create a web of digital twins, why it's important to have those real-world use cases, particularly when prototyping, and how we can make the data infrastructure for infrastructure data. So enjoy the talk, take part in the conversation on the Digital Twin Hub, and share your views using the hashtag Digital Twin Talks.
Hello, my name is Olivier Theroux, and I'm the Head of R&D at the Open Data Institute. The ODI is a global nonprofit working with companies and governments to create a world where data works for everyone. That is, we want to make sure data can be accessed and used to make better decisions while avoiding any harmful impact. And today I want to talk to you about some research activity that we have been conducting at the ODI for roughly 1 year, using a mix of methods ranging from interviews, prototyping, workshops, and learning from other domains and from the past. But first, let's try and agree on a definition of what is a digital twin. There's actually quite a few definitions. Here's one, focusing on the interpretation of digital twins for the built environment sector. Here's another. This one is from GE. It's slightly broader in scope, and it focuses on the purpose of twins. But we can agree that digital twins, across those definitions, is about using data to make digital models, which are then used to make better decisions about physical assets. It feels like it's an emerging topic, but it's actually not new. It's been used in domains like jet engines for many, many years, and we can actually trace it to the Apollo missions and the concept of digital mirroring. It's mature in some domains too. Formula One has been using digital twins for decades, and there are many sensors used to make decisions real time about the car. What is exciting is that, as our research shows, in the UK and in other countries, the term is now starting to become quite popular beyond those domains, and it's being adopted across sectors. The reason is that the availability and low cost of a number of underlying technology enablers is making it easier and cheaper and more valuable to start adopting this methodology. For instance, in the UK, we have seen some adoption in the water sector. There's enormous promise in the application of digital twins on physical infrastructure. You can, for instance, use it to manage and predict incidents, to predict the ideal response to everything from a burst pipe to heavy rainfall. What's interesting there is that unlike a jet engine or a Formula One car, we're talking about really large-scale things, not just a pipe, but a whole national network of water infrastructure. But conversely, a digital twin does not have to be extremely big, complex, and complicated and sophisticated. At the ODI, we built some rather realistic digital twin prototypes using a mix of hardware and open source software, largely from the IoT stack. It's important to realized that digital twins is not a technology nor a solution. It's an approach. It's an approach to collecting and using data about physical assets to make better decisions about those things. We can think of digital twins as a loop. It's a loop of data and decisions. Observations, on the top left here in this diagram, are made about a physical assets. That can be, data, sometimes real-time, sometimes not, but always at the right level of precision and granularity to help with the twin's purpose, is being collected. The data can be fed into models, predictive models, analytical models, or visualized. And those models and visualizations are the basis of insights about the asset and the world around it, which result in decisions about the asset. Those decisions can be small or large scale, such as moving something by a millimeter or investing £1 billion in building a new plant. They can be immediate, real-time, or long-term. When enacted, those decisions lead to outcomes which in many cases can be measured, and so we repeat the cycle for as long and as frequently as needed for the purpose of the twin. What's interesting with this diagram is that it's not necessarily a closed loop. Indeed, we can in fact look at it as a series of inputs and outputs. The raw data from sensors and measurement can be used by others. Software and models may be shared with other owners of similar assets. A digital twin may also use as input to its modeling and predictions data from the outside world, maybe weather data, but also possibly data processed and shared by another digital twins. This, in theory, makes sense, but in practice, it also needs to make sense in a world with a number of different actors with different motivations. Public policymakers need to make decisions. Utility providers need, as do asset owners, to maximize value and minimize risk. And that creates barriers to this input and output perspective, and it creates barriers to sharing of data. The built environment sector has a culture of precaution and risk avoidance, and it's also a typically very competitive environment, which may cause resistance to digitization and sharing of data. But ad hoc sharing already exists through things like data requests, hack events, and we know that the built environment industry has a solid track record of creating standards when they make sense. From our research, here are just a few early examples of sharing in this domain. Daphne is a platform that allows engineering researchers to share and run data, models, and workflow. Northumbrian Water uses a model from Newcastle University and then shares data and models with Daphne. And that actually goes hand in hand with our knowledge about the variety of a rich and varied set of practices for data access, which range from open data to marketplaces, collaboration and commercial value exchange around software, and the decades-old experience of building technical standards by convening whole industries. Here on the screen is a representation of that variety in something we call the data access map. But what's interesting here is that we're talking about not just data sharing at the raw level, not just, oh yeah, here's the raw data from my sensor, but actually we're talking about data infrastructure. Because some twins will be very similar to warrant sharing. So they might have different similar purpose or use similar type of assets or be in a similar sector that will warrant sharing, collaboration, pooling, convening, and value exchange. The common types of twins may require or lead to standards. Common toolings and methodology will emerge. Many twins will likely use common reference data such as registers and vocabularies. And in some cases, data access will be granted to others, maybe other twins or maybe just other actors, directly or through intermediaries. And so now we have the basic building blocks of connection between twins. And what happens if we scale that up? As those connections develop, so will networks of twins be created and stewarded in many different sectors and industries. But we can, again, conceptually, understand that there might be very, very different networks emerging. Some networks might be quite small, just a few twins connecting through direct data exchanges. Sometimes you might think of a huge network of thousands or millions of digital twins through shared vocabularies or shared standards. So there is not a single topology or a single purpose of that network of twins, and there's not even a certainty that there will be one unified network of twins. But what we do know is that there's a possibility of scaling up digital twins networks, but it can play out in many different ways. And some futures might be better than others. For instance, you might end up with digital twins stewarded by small group of competing commercial bodies, which could create a lot of value and make the ecosystem easier to evolve because they would control it, but perhaps less interoperable if you have, an oligopoly with 2 or 3 big ecosystems. Then you would have to choose whether your digital twin follows this or that ecosystem, but they won't be talking to one another. Smartphones ecosystems come to mind for examples of how that plays out. So at the ODI, we ran a number of workshops to explore how those forces and societal and economic forces may shape the future of the digital twins network. And, well, it was hard, largely because we did not have many concrete use cases to explore. And that is something that I'll get back to later. We need more use cases to understand how to grow the network of digital twins. But we did figure out a few core principles from the ground up that if we want to create an open and trustworthy network of twins, it would have to follow at least 4 core principles. 1, it would have to be federated. That makes sense if you think about it. If you think of a single digital twin of the world or even of a city, that becomes quite unwieldy, and actually it goes against the reality of the fact that the physical assets that you will be represented and modeled are actually owned and operated by very different organizations with competing motivations, and therefore the idea of centralizing the modeling and decision making doesn't quite make sense. So the federation is pretty obvious. It would also never be complete. That also is conceptually sensible. New infrastructure is being decommissioned and built all the time, and it would be impossible and of limited value to connect every twin to every other twin once and for all. And so we need to have something that's going to be evolving. It would also have to be cross-sector. That's a little bit harder to infer logically, but we know that there might be networks happening within sectors because they will have similar assets. But creating connections across sectors will allow us to ask questions at level higher than the single twin or a single organization. For example, how does transport affect energy usage? How does energy consumption and production allow us to infer decisions about housing, for instance? It would have to be for everyone. It would have to, of course, benefit the asset owners, but ideally, because the aggregate of information generated through digital twins would help make decisions at national policy level, we need a way for this to work for everyone. This set of principles is actually not very dissimilar to those which led to the global spread and adoption of the World Wide Web, from its invention as a simple set of formats and protocols for sharing information to being enmeshed in every part of our lives, interactions, and commerce. Those 4 principles are actually fairly similar to a set of principles that have been created here in the UK called the Gemini principles. And that's a reflection of the fact that there are many ways to create a federated cross-sector web of digital twins. And given that it is expected that this network will be created over many decades, we need guidance to be both strong and flexible. The Gemini principles are a good start to that, but they too are quite ambitious, quite broad, and there are grey areas of trade-offs and compromise between the various Gemini principles. For instance, between openness and security. You can't be 100% open and 100% secure. You need to find the places where security is more important and the places where openness is more important, and find the right trade-off. And so to understand and navigate those trade-offs and this balance, we looked at the past, especially the early 20th century development of electrical grids in places like Chicago, London, and Berlin. And they took on very different topologies in response to differing views about centralized versus decentralized authority, public versus private ownership, and the amount of steering necessary to guide the development of large technical systems. And that validates, to some extent, our hypothesis that there is no one way that to build a global network of digital twins. And there might actually not be one right way. Different network topologies are possible and will likely exist alongside each other over time, and that is probably fine. Hypothetically, mirroring what we saw with the electrical grids, at first the US, the UK, and Germany could pursue entirely different approaches to networking digital twins, as they did with electrical grids a century ago. And so this might sound like saying that there will be competing networks, but I want to end on an optimistic note that came from our work on prototyping, and that is that we are at the moment creating the basis of data infrastructure for infrastructure data. Our experimentation with creating networks of twins, building on real-world use cases and existing technology from the world of IoT, led us to 3 insights that I want to add to the principles that we looked at earlier. First, protocols matter. Now that makes sense. No matter how data is represented internally to the digital twin, the moment you start sharing, you need agreements on how to do that. Second, insights may be just as important or even more valuable than data. Sharing between twins is not just about the raw sensor data. If you are creating predictive models about a wind turbine, then that might be more useful than just raw data about the state of your turbine. And actually, you may even want to share just the insights about when your turbine may need repair in certain conditions. And so there is a hierarchy of value in different contexts between the raw data and the insights. And finally, when we think about connecting twins, we typically think about, a mesh of direct real-time access to data about the twins. But there are many other ways, like pooling of a record of decisions through a third party. It is likely that intermediate things like data hubs will act as buffers in data pools, and those will likely offer the industries better assurances of independence, security, and control, which will lead possibly to better adoption. And what we're talking here is the building of data infrastructure, which will create the basis for the growing of a network beyond just boundaries that are regional or national. So what did we learn through our research? First and foremost, that the concept of a twin is maybe still emerging, but it scales. Because digital twins are inherently connectable, because you can think of them as a set of inputs and outputs, it is easy to envision creating a network at the scale of a country and beyond. The notion of a network of twins, even a large-scale web of twins, is not only possible, it is also desirable because it creates value beyond a better operation of a single digital asset. It creates the possibility of better decisions at the national policy level, it creates better knowledge across sectors, and it creates the possibility of insights about our world much beyond the repair of an engine, for instance. But making this reality will take a lot of time and effort. We've talked about the fact that creating this network of digital twins is likely going to be taking decades. And the history of large technological system teaches us that the emergence of an open and federated web of data about the physical world, which would create value for all, is not a given by any means. And what do we need to create that is a bottom-up and top-down approach. We need to create richer use cases across sectors and actors to help buy-in of this notion of a web of digital twins. We need to continue developing the right principles, building on things like the Gemini principles, and we need a shared language to steer this evolution. All of that will be crucial to making the web of digital twins as pervasive and successful as the World Wide Web has been. I want to thank you for watching this video and mention that all the outputs of this research on digital twins at the Open Data Institute are available openly and freely online at theodi.org/project/RD Digital Twins. This includes podcasts, week notes, interview summaries, and a lot of blog posts. If you have any thought, if you have any comment, if you want to get in touch because you agree or disagree with this talk, or indeed if you want to collaborate with us further on this topic, please get in touch. Thank you for watching.